Everybody, and welcome to the Noel for GCSE live stream. So, sorry for the delay. There's been a lot of issues with trying to get connected. I hope you can hear me. And if you can't hear me that well, do let me know. I'm also live streaming on TikTok as well. So, just in case any errors happen and you can't hear me on one, maybe try and go to the other. But yes, I would recommend going to YouTube because I can see the chat there much more easily and watch it there. So in this live, it's so lovely to see you guys here. And also, I hope your exams went well for those of you who did computer science paper today. Okay. So in this live, we're going to be going through, yeah, I can pin that. Second. In this live, let's go through all of the topics, and we're going to be going through loads of exam questions per topic. So take notes on the questions that you feel uncomfortable and you don't understand and know how to do them. It's important to remember also that these are the questions that most students get wrong in past papers. And another thing, these questions also are likely to come up because they come up quite a lot. The fire alarm went off during one of your exams. Ironically, the same thing happened to me when I was doing GCSEs. The fire alarm went off when I was doing GCSE engineering. So that was quite interesting. But yeah. Okay, so hopefully you should be aware of all of the topics. This is going to be, thank you. Hopefully I do get 100k subscribers. If you're watching on TikTok, I recommend you come onto YouTube because then I can see your answers. So we're starting off with the first topic, which is energy. Any advice for how we should do this? So I would recommend answer the questions with me. The answers will be covered up and I'll go through them afterwards. And therefore, it's really important that if you don't get the question, make note of it because these questions come up almost every single year. So it's really important to focus on them. Okay. Thank you for those sharing the live on TikTok. This is beneficial for Edexcel as well because the chemistry and biology ones, some people said that they were beneficial for the actual Edexcel exam board, and some of the questions came up. So it should be there as well. Okay. So I hope the questions aren't too small. Let us begin. Looking at the first question. So the first question is, why can't all electricity be generated by solar power? So there's a lot of chat, so I can't reply to everybody, but yeah, I do remember you guys. So why can't all electricity be generated by solar energy? As people are saying in the chat, well done. Solar energy is not always reliable. It relies on the weather. It takes up lots of room. It's visually pollution. It's visual pollution because you might not like the look of it. And yeah, there's a lot of disadvantages. It's not very efficient because you're relying on weather patterns. So you can see here a really large area of land would be required. That was what was in the mark scheme. And on top of that, there was low useful power output because of all of the cells. Okay. Moving on to the next question. Give two advantages of gas power versus coal power. So what is the difference between those two fossil fuels? So have a think. So this question was, the mark scheme for this question is focused on the products of the gas versus coal. So there's no sulfur dioxide released, whereas in coal you do, and there's less carbon dioxide released. So there's a smaller global warming impact. This is for combined higher and triple, and I won't go any lower than that. This is for those two main groups. There are some triple topics on here. We're also going through all of the required practicals, which are super, super important as well. Gas power. So when you've got fossil fuels, you've got oil, coal, and gas. Those are the three different methods. So gas comes from shale gas. It's literally compressed gas. I don't know how else to explain it. And that's pretty much all you need to know. Okay. Moving on to the next question, which is explain why at the bottom of a slide, all of the riders on their sleds have approximately the same speed. So this requires you to really think and focus on the physics side of things. So at the bottom of a slide, why do all of the riders on their sleds have approximately the same speed at the bottom of a slide? So why is that? Let me see. Does anybody have any good answers? What is interesting here is people saying goes flat. So what they wanted you to do was talk about the equation. So when we're looking at speed, kinetic energy, speed is equal to kinetic energy is half mass times velocity squared. And exactly, well done for those saying that. So it's half mv squared. Now, each of the different people going down the slide, they have different masses, of course. But what you notice is what's happening here is you've got your kinetic energy and it's being transferred into gravitational potential energy. So when you equate the two, they cancel out the mass on both sides of the equation. So your speed doesn't depend on your mass anymore, and therefore everyone eventually reaches the same speed. Okay, so does that make sense, everybody? I am going over all of the topics. Yes, I am. Hello, everybody who's just joining. I'm going over exam questions that go over all of the topics. And on top of that, I'm going over all of the required practicals through exam questions, i.e. everything you need to put. Okay. So moving on to the next one. Describe the force that acts on the student's hair in figure 12. So obviously you can't see the specific diagram here, but what's happening here is it's describing why is somebody's hair standing up, and what you've got to say is there's a non-contact force of attraction between the charged head and the balloon. So the drawing was when somebody had rubbed a balloon against their hair. And why did the hair start to stand up? Well, that's because there was electrons started moving, and as electrons started moving, oh yes, Mahim, I need to make you a moderator as well. So as electrons start moving from the hair to the balloon, there's a difference in charge. And therefore, when there's a difference in charge, opposite charges attract. So your hair attracts towards the balloon and your balloon attracts towards the hair. So yes, electrostatic forces of attraction. Well done for those of you saying that in the chat. Amazing job. For those of you watching on TikTok, come to YouTube. It's so much easier for you to answer the questions. Okay. Continuing on, different people have different speeds at the end of the zip wire. Explain why. So in this case, it's kind of the opposite of the question we just looked at. So at a zip wire, you've got to understand as you're going down a zip wire, what's happening is you're moving from normally a high up area going down, and you're using whatever you're holding on to go down that zip wire. So why would people have different speeds? Well, what affects the ability for you to move through air? Well, you've got air resistance. So what affects air resistance? Exactly, surface area. So different people have different surface areas, so they will be affected by air resistance differently. Whoever is more aerodynamic is going to be much more better in getting through. Or another thing that they actually mentioned in the mark scheme, which you can see, is that the initial speed might not be zero, which would add to the total amount of energy of the system. So what that means is that initially, if your energy is not zero, you might not have started from perfect rest. So people have different starting points, and therefore the ability for your speed to go slower will be different for different people. And it's not just necessarily weight, as people are saying, like it can also be if you're wearing a jacket, you're taking up a larger area. So it's almost the parachute effect as air goes into your jacket and you're being pulled back, friction. Okay, so it's not just your mass. Moving on to the next one. Explain how a meter ruler would have affected the accuracy of a student's measure of width. Here you want to talk about the disadvantages of using a ruler pretty much to measure anything. So as people, yeah, well done, Sylvie, that's correct. So a meter ruler has low resolution, especially compared to other things that you can measure with. So as people are saying, well done, Mohammed, well done, Rami, well done, Joanna, lower resolution. That's a key term there. And then you also want to say it's therefore less accurate because of that. For example, you can use something called the micrometer screw gauge. If any of you are interested in doing A-level physics, then that is something that you will be familiar with and actually start to use, but it's a much more accurate way of measuring things. But yeah, some people are talking about how there's different errors as well. That's true as well. In this case, it said less accurate. You can also say less precise, 100%. A vernier caliper, that's another thing that you can use. Well done, Jude. Okay, and moving on to the last question of this slide, which is the maximum speed that a cyclist can travel on a level road is 14 meters per second. How does cycling uphill affect the maximum speed of this cyclist? Explain your answer. Okay. Thank you for everybody joining on TikTok and everybody joining on YouTube. Come to YouTube, it's so much better there. This is on the Noel for GCSE YouTube channel. Okay, so I can see people's answers in the chat. So the maximum speed the cyclists travel on a level road is 40 meters per second. How does cycling uphill affect the maximum speed of the cyclist? So what you want to say is the maximum speed is lower because the maximum power output of a cyclist, and we're not talking about power in terms of electricity, we're talking about power in terms of kinetic energy and movement, the mechanical side of things. So additional work is done against gravity. So some of the energy from the cyclist isn't going from chemical energy stored to kinetic. Some of it is also going to gravitational potential energy. So it's moving to another store rather than all focusing in on movement and kinetic energy. Well done, guys. You're answering really, really well. And for those of you who are trying, I value that as well because it's good to keep trying and answer as many questions as possible. Okay. Thank you for everybody joining. So continuing on. Sorry for those who are saying things on TikTok. I can't see what you're saying because I can only see one screen at a time. So maybe come onto YouTube and then you can ask your questions. Okay. Moving on to the next page of questions. So the first, that is going through the same page of questions, ironically. Let me just go through those. This live stream is probably going to be maybe an hour more than we've already spent. Actually, going through that, so you can see the answer to the last question there. The maximum speed is lower because the maximum power output of cyclist is constant. This was quite a heavy marker question, so it required a lot of steps. I don't have that fancy of a stream thing set up. I wish I did. Okay. So moving on here, and next you can see that we've got our first required practical. So nearly 300 viewers, that's amazing. Thank you for telling me. Okay, so first required practical, which is about thermal insulators. So you've got diagram here, and this isn't just a diagram, it's got all of the things that you need to remember for the exam and some key points to remember. So you've got two required practicals. So the first one is the thermal insulators. So you're measuring the effectiveness of using different materials as insulators. So for example, if you're measuring how effective using a certain cloth is compared to using a wool or carpet is going to be much better. Okay, we'll do a Kahoot at the end. Thank you for saying that I'm better than exam AQA or exam QA, whatever it's called. That's very kind of you. Okay, so you've got the diagram here. I would say, guys, everyone make notes from this page, because from this page, it has all of the notes that you need to know. So you've got the diagram. This page here is for the second required practical, all of these notes. So it's because the first required practical, I could do a drawing. Would you like me to draw out the first required practical? I can do. Let me try. Or you know what? I don't think I can. Thank you, Rami. That is so kind of you. Okay, I'll just talk through the first practical because it's not letting me. One sec. Let me try and get mirror up, and then I can draw it and go through the first required practical. It's important to go through all the required practicals actually, so it's good we're not skipping on any. And also, I would recommend watching videos. I know Primrose Kitten has a lot of really good videos going through the required practicals, like physically doing them. So that's quite helpful, I would say. Okay. So going through the step, physics and maths tutor is also really good for the steps. So let's go through them. And for the people on YouTube, I'll share my screen. Yeah, and I'll explain what questions they can ask from this as well, but they might come up with some new ones. This first required practical, I've never really seen too many questions on it, which is interesting because I don't think it's that used as much. So the purpose of it is to investigate the effectiveness of using different materials as thermal insulators, i.e. which material causes the temperature loss to be the smallest, i.e. that is the best insulator because it retains all of the heat in the beaker. Okay, so you've got the equipment list. It's not necessary to memorize this, but just be aware of the different things you need. And here are the different materials that are often used. So looking at newspaper, bubble wrap, polystyrene, cotton wool, etc. Okay. So testing, there's two different methods as I spoke about in the page. So you've got testing different types of materials and then testing the same material but looking at the different thicknesses and how that affects the temperature. So you set up your equipment, you wrap 4 of the 5 beakers with different insulating materials. Let me just draw this out. So imagine you have your beaker, and obviously you have your kettle. I'm not going to draw your kettle. And you heat up water and you put a certain constant volume of water, for example, let's say 40 centimeters cubed in your beaker. And then what you're going to do is wrap 4 of your 5 beakers. So you do this with 5 different beakers so you can test them at the same time. You cannot see. I'm so sorry. Oh, on YouTube you can't see. Sorry about that. Sorry, I just saw those. Hopefully you can see now. Okay, so going through that. So there's 2 different methods, testing different types of materials and testing different thicknesses, as I mentioned. So what you want to do is you want to start off with a beaker. Either you can do this with a beaker, that same beaker, keep heating the water and doing it, or using 5 separate beakers. And then what you're going to do is you're going to wrap each of those beakers in the different insulating materials. So, and you're using rubber bands to secure them. So what you want to do, for example, you might wrap this with a single layer of cotton wool, for example, and then ensure that it stays on using an elastic band. In this case, however, you can't just use a single layer of newspaper because obviously a single layer of newspaper is a different thickness to wool. So you might want to make it the same by ensuring that the width is the same of each. Okay. Now, let's see what's next. So the beaker with no insulation wrapped around it is a control beaker. So there's a control beaker to measure just how generally one of the beaker's temperature changes. Okay, and then you're going to cut circles of cardboard. This is the thing that people forget. So obviously, if you just have the beaker open, heat is going to escape, and that won't make it fair because it will escape at different rates. So what you're going to do is you're going to cut circles of cardboard, but you need to make a hole in it, in each of them, so that you have your thermometer. So you then cut your circle of cardboard, you make a hole so that you can put your thermometer in to measure the changing temperature, and you put cardboard for each of them. So don't confuse cardboard as one of the materials you're going to wrap around the beaker. Don't make that mistake. Okay, so that is the testing different types of materials. So obviously, for a period of time, you're measuring the changing temperature. In this case, it's every 3 minutes, and then you calculate the changing temperature for each beaker and see which one has the lowest change in temperature. That's the best insulator. The other method that they might ask you to talk about is looking at how the thickness of one insulating material affects it. For example, you might have 5 different beakers, and then with each beaker, you have a different number of newspapers going around it to talk about the thickness of newspaper. Okay. Safety precautions. This is something that I have seen a question on before, so make sure you're aware of the question. Don't handle the beaker whilst or after heating. Keep the beaker on a heat-proof mat, because obviously you don't want to burn your hands, and especially using a kettle, you need to be careful with that. Often your teacher will do it for you. Take care of handling the glass. Obviously the glass can be hot itself, and if the beaker appears cracked because maybe you used too hot water, then don't use it. Use another beaker. And if a beaker breaks, use a supervising adult. So there will obviously be a limit for the starting temperature of the water because you don't want it to be too hot. This is what your table of results should look like. This is for the one where you're looking at the different materials. Over the different times, you record the temperatures, and then you record the overall change in temperature once it stopped changing. Okay, and that's it. So let me go back to the PowerPoint. So this should be triple. Okay, this is triple, I believe. So, okay, that was the first required practical. And the second required practical, I've done a little nice diagram for you on the right, so copy that if you need to. It's looking at specific heat capacity. So, looking at this, what have we got? So we've got a diagram, and on the diagram, we've got a beaker. We've got 2 stick-like looking things. So the first thing is a thermometer to measure temperature change, because what is a equation for specific heat capacity? Well, we know that change in energy is equal to specific heat capacity multiplied by mass multiplied by change in temperature. Okay, this is for combined higher and triple. So that is the equation for with specific heat capacity in it. So obviously we need to we need to account for temperature, and therefore that's what the thermometer is for. Now, what other parts of the equation do we need to find? Well, we need to know the mass. So we can calculate the mass of the water by finding the volume of the water, knowing the density, and then converting it. Okay, so in this, we've got a beaker, you've got a balance to show the mass. So sometimes you can just go straight into finding the mass. You don't have to do that volume density route. You do it on a balance. You then connect it to an immersion heater. So an immersion heater is a thing that heats up the water. It's kind of this metal block. And in this case, we're not doing specific heat capacity of water. We're doing the specific heat capacity of oil. So you're going to record the mass, the initial mass, and start the stopwatch. Now, a question that they often ask is, how can you improve this practical? You can say, well, if you wrap it in insulation or foam to reduce energy loss so that your specific heat capacity is the same. No, you're not supposed to see something. It's just the PowerPoint. I'm just explaining the right-hand side. So you should, yeah, that's all I'm showing. Yeah, I'm not showing any page. Yeah, the diagram's on the screen, guys. Yeah. So yeah, because the reduced energy loss from the insulation improves the accuracy. Now, you're going to connect the immersion heater to a joule meter, and you're then going to time it for 30 minutes. You're then going to read the number of joules of energy passed into the immersion heater. Now, looking at the specific heat capacity equation, you've got the energy change, you've got the mass, and you've got the change in temperature. So what can you now calculate? The specific heat capacity of oil, and that is the overall intention there. Now, I put a key point at the bottom, which they could ask you about. What are some sources of inaccuracy? Well, you can say the energy passing into the air. And now here you can steal your ideas from the previous practical. Just put cardboard over it and put and leave a hole for the temperature and the immersion heater, for the thermometer and the immersion heater. Another thing is that not all energy passes into the oil from the immersion heater, because there could have been some energy loss there, and that is a bit harder to do. You can just try and ensure that the immersion heater is fully submerged. Okay, so hopefully that required practical takes you back and you understand everything. Now, on this next page that you can see, I've actually put the diagram for the first practical on the left-hand side. So if you wanted to make any notes from that, just going through that. You can see that on top of us putting cardboard on top, we put it in an empty beaker in our diagram. And that even more reduces the amount of temperature going out. This is for AQA, but it's also suitable for Edexcel, okay? This is for paper 1, combined higher or triple. Thank you, my GCSE maths. I see you in the TikTok chat. Thank you. Okay. So now on the right-hand side, we've already explained that previous practical. So looking at questions for the specific heat capacity practical that you could be asked about. And I've also put the mark scheme here so that I thought specific heat capacity was the temperature required to heat up 1 kilogram of substance. Yep, that is correct, by 1 degree Celsius. That is correct. So you do further calculations to help that. Question for specific heat capacity. So that you could be asked, explain how the internal energy of the water changes as it heats from 20 to 25 degrees Celsius. So you can say the mean kinetic energy of the particles increases, which increases the internal energy of the water. That's i.e. how heat is transferred through convection currents, okay? So, I hope you've had enough time now to either screenshot or take notes of the mark scheme for the required practical. That's kind of the structure that they want you to write the method that it's happening. So wrap a certain number of layers of the newspaper around the metal can. That's just an example that you're asked to talk about in this context. Use a Bunsen burner or heat water in a kettle, probably heat water in a kettle. Put the hot water in the metal can or whatever substance. Use a measuring cylinder to measure the volume of water, so that you need to talk about which ways you're measuring things, using a measuring cylinder or using a meter ruler or whatever. You always need to mention what measuring instruments you're using. Calculate the temperature decrease, use a stop clock. Oh, key important thing, make sure you always say start the stopwatch and then say record the values at increments, at like 1 minute increments, or however many times you want to keep recording the new temperature. Use the same volume of water each time. In that case, that is the control variable. Another good technique is actually, when you're talking about methods for required practicals, literally labeling independent variable equals control variable equals dependent variable equals, and that should help you guys. Okay. So we're now on to electricity. Okay. The Leslie cube is important as well, but isn't that a paper 2 topic? Yeah, that's a paper 2 topic, isn't it? I'm not too sure. Yeah, because that's in the topic of light and sound waves or something. Do tell me if it is, and then I'll go through that. But I'm only going through paper 1. So, electricity. Oh, even more pictures of required practicals. I'm sorry if it's difficult to see that, but I'll go through them now. We didn't go through renewable resources, disadvantages and advantages. We looked at a question at the beginning, but yeah, you can. We looked at a couple questions, but I didn't put them in here because I know that a lot of people know about renewable and non-renewable, so it wasn't a common mistake question. But you can talk about them in the chat if you want. So let's go through some of these practicals using the whiteboard. So hopefully everybody can see. What we've got here is the first required practical is looking at drawing IV graphs. So IV graphs, you've got current potential difference graphs. Now, if you don't understand anything about electricity, current, voltage, potential difference, what any of those things mean, I would highly recommend you, oh, you can't see my screen. I would highly recommend that you watch my series, which is actually A-level physics, but the first couple of videos are suitable for GCSE. So watch the ones that say GCSE on it, because it explains everything from literally particles of energy. It explains everything. So it's a really good way if you don't have any understanding of how potential difference or any of those things work. But if you do, just that's good as well. So they could ask you to carry out the required practical where you want to gather the current potential difference graphs on different components. What would the circuit look like? And you would have to be able to draw it and explain why it is a certain way. Okay, so going through what it would look like, we have, this is triple, so I'm just trying to do this with my mouse, so sorry about the very questionable drawings. You're going to have your voltage supply. Let me make this a bit zoomed out. So you're going to have your voltage supply, i.e. whether it's your battery or your cell, and then that is going to be connected to your ammeter Okay, now what does your ammeter do? Your ammeter measures current. I realize that some people on TikTok can't see this, so I'll zoom out a bit. So you've got your ammeter, and then we'll talk about why the ammeter is connected like that. And then what have you got? Well, you've got your component. Now, depending on what component you're measuring, you put the component here. So I'm just going to call that C because it depends. If it's a filament lamp, obviously it will look like this, i.e. if you're trying to draw a current potential difference graph for a filament lamp, that's what it would look like. Oh, we've hit almost 300 people. That's amazing. Thank you guys for all turning up. I hope you're finding this resource helpful. So you've got whatever component that is, and then across the component, you've got the voltmeter. Remember, voltmeters always have to be across the component that you're measuring the voltage of. Otherwise, it wouldn't measure anything. And then you've got a key thing here that people remember because people often finish the circuit at this point. But no, you've got something called a variable resistor. Now, the symbol for a variable resistor is effectively a rectangle with an arrow going through it. Okay, so this is our kind of our circuit setup. Now, we've got our ammeter because current is the reason why we have certain positions is because of our knowledge of how current works and how potential difference works. So current, we know, because this is a series circuit, current is going to be the same anywhere in this series. So you can put the current anywhere. However, with the potential difference changes across the circuit. So that's why we need to ensure our potential difference, our voltmeter, is directly across the component. Now, a key term that you guys need to be aware of is ohmic conductors. So what is an ohmic conductor? Well, an ohmic conductor is anything that has a constant, direct, proportional, linear relationship with resistance and potential difference. Okay, as long as there are all standard conditions are kept constant. Oh, I realize people on TikTok still can't see this. As long as there are standard conditions kept, i.e. that the temperature of the environment stays the same. Okay. Now, what are the steps now? What we're going to do? So we want to calculate we want to get a set of results so that we can draw a current potential difference graph. Now, normally voltage is on the y-axis and current is on the x-axis. How do we know? Well, what we're doing is the dependent variable, the thing that we are, the independent variable, the thing that we are changing is often on the y-axis and the thing that we're measuring is often on the x-axis. But it doesn't really matter sometimes. If you're making your own practical, it doesn't matter which way you do it. So what you want to do in this situation is you then want to get values for your voltage and you want to get values for your current. So how do you do that? Well, you're going to start with drawing a table. So you draw a table, and in your table, well, notice we've got a variable resistor. And what does the variable resistor do? Well, it changes the resistance. So what are we doing there? We're going to turning the knob of the variable resistor. We get loads of different values for the resistance. Now, obviously, there's different ways to change the current or the potential difference. So whatever way works for you. In this way, we are changing the variable resistance. So we're changing that, and then with each of that, we're going to use the ammeter to measure the current value, and you're going to use the voltmeter to measure the respective voltage value. Okay. And then there you go. You've got different values of resistance, different values of current, different values of potential difference. You can then plot a graph with this. And once you can plot a graph, you can then highlight the relationship between current and potential difference. Okay. As I said, if you don't understand any of the relationships, do watch my videos. They go through all of the graphs. They go through everything you need to know from the very basics. So the method that you want to talk about, I'll show it back on the screen now. You should be able to see this. so those on TikTok can see. So you should be able to see that you've got set up the components with a 6-volt DC power supply. It doesn't really matter what your power is. Place a variable resistor in series. As you can see, the variable resistor is in series, and then you're going to place the ammeter also in series and the voltmeter in parallel, as people have been saying. You record the potential difference, you record the current, you alter the resistance through the variable resistor, and you record the respective current and potential difference values. You then take 3 current readings, you find the mean, but it's not necessarily to find the mean, you just want to draw the graph. That's your main aim here. Okay. So does anybody have any questions? Because I don't know how well that was explained. I tried to go through it as best as I could. So that's the first practical. If anybody has any questions, let me know. There's a lot of people on here, so I can't really respond as quick as possible anymore. I don't see any questions. Can you explain variable? So the variable resistor is the thing that literally it changes the resistance of the thing. So I can explain it through actually your knowledge on something else. So I'm just quickly going through and explaining variable resistance. So what you have in variable resistance, well, this idea that you've got a wire, right? You've done this practical, hopefully. It doesn't have to be coiled necessarily. So you've got a wire, and you've probably done this practical. It is a required practical. It's the next practical, actually. You have 2 crocodile clips, and what you do is this wire is attached to a meter ruler, and then you've got all of your circuit components, your voltmeter, your current, your ammeter and stuff. And what you do is you move your crocodile clips so that the length of the wire that the current is flowing through and the voltage is flowing through gets bigger and bigger and bigger. Now, as that gets bigger, what do you notice? The resistance gets bigger. So as the length of the wire gets bigger, the resistance gets bigger. Now, why does that happen? Is anybody able to explain in the chat why does as the length of the wire increases, why does the resistance increase? If you don't know, that's perfectly fine as well. But they could ask you that, so it's worth at least understanding it sooner or later. Is there more space for the current to travel? Exactly. So as people, yeah, well done. The electrons are colliding more. So as the current goes through the wire, okay, you can imagine it like a corridor. This is an example I used in that video that I was talking about. So you've got your metal particles, as people are saying. So as it has to go through the wire, what it's doing is the current has to collide and then get out as they get out of the wire. But as the length of the wire increases, that means that the number of collisions that the current has to go through increases. And that's why as the length increases, the resistance increases. There's a longer pathway, therefore there's more ability for that to happen. We'll be going through questions later on. Okay, I hope that makes sense. We're now going to go back onto the documents. Thank you for those of you on TikTok. And those of you on YouTube. Okay. So then you have the second practical. So this is looking at how you can change the current, but we already spoke about that, how you can change the current in a wire, and that's really important to focus on. Okay. That is a practical I was talking about. So if you are unaware of the actual circuit structure of how you should do that. Again, the voltmeter is across the meter ruler as it's across the component. And then you've got the ammeter, again in series, the power supply, which is only 1.5 volts this time, because why do you want to have a lower voltage thing when you're using the meter ruler practical? Well, you don't want to overheat the wire, because if you have too much electrical current flowing through the wire, remember, we're starting with a really little bit, so it will overwhelm the wire, and therefore it can get really hot. And if it gets too hot, then what can happen? Well, you can burn your fingers, and that will be a health and safety risk. Okay. Now I've listed at the bottom there different types of errors on top of the method. So you've got systematic errors, such as the voltmeter and ammeters should start from 0. So I've realized that I think in one question before, in one of the exam questions that they'd asked once, they actually asked you to name a specific error for that practical. I think it was a random error. And a lot of people were giving systematic errors. So that's why I differentiated it on the left for you. So systematic errors are when the voltmeters and ammeters start from 0. A random error could be when too much current affects the temperature. So it will give the ammeter very crazy values as the current gets too high. And then you can reduce this by reducing the length increments, because in this case, we were increasing the length every 10 centimeters. So how do you reduce the effect of that happening? Well, instead, you only increase it by 5. So you get a smaller range of temperatures. You do not overwhelm the wire with current. You can see the graph that should be plotted from this practical on the right-hand side should be straight line through the origin. In this case, because talking about the directly proportional relationship, but if temperature has affected your results as the wire's temperature started to get hot, maybe you recorded it just to check, then it's not going to go through. Okay. And you've also got 0 error there, which is when the ammeter displays a reading when you haven't even plugged anything in. So a way to measure and account for 0 error is at the end of the experiment, unplug everything. And if you see that the ammeter still holds a value, then what do you need to do? You need to go and get rid of that. And with each value that you have, you take away that 0 error value. So if it says 2 amps when you are not connected to anything, you take 2 amps away from all of your values. Okay. Now screenshot that if you wanted to take any notes. If not, we're going to the next topic, which is particle model of matter. So notice how there's a lot of practicals in that one. Okay. Sorry. For those of you on TikTok, I'm sorry, I can't make this page any bigger, so that's all you can see, really. Sorry about that. Okay. Moving on to these questions now. So describe in terms, am I sharing? Yeah, I am sharing the PowerPoint. So back to answering questions, guys, make sure you put your answers in the comments. Describe in terms of energy what happens when a substance changes state. So what is the energy transfers that are happening? So in terms of energy, you need to speak about potential energy and kinetic energy. So potential energy is energy in relation to the position of each other. That's what potential energy means. Whereas kinetic energy is energy and motion. And what happens to both of them? So in the case of changing states, potential energy increases because breaking the bonds between them, it puts them further and further apart. On the other hand, however, when we're talking about kinetic energy and changing states, the kinetic energy remains the same. So that's the key idea. When you're changing states, potential energy changes, however, kinetic energy doesn't change. Okay, it remains the same even though the substance is being heated. Moving on to the next one, which I should not show answers for yet. Okay, low specific heat capacity means high specific heat capacity means. So what does specific heat capacity actually mean in relation to understanding it? We know the definition, the amount of energy required to increase 1 kilogram of substance's temperature by 1 degree Celsius without any change in state. So what do they actually mean? Well, low specific heat capacity is when if something has low specific heat capacity, means something cools and heats really quickly. For example, water, it boils really, really quickly. It's a good electrical conductor, for example, copper. High specific heat capacity means it takes a lot of more time to heat and cool down, and it's useful for heating in homes because it's got this sense of it can be used as an insulator. For example, water. Now, a useful thing that you can apply this to is when you're thinking about when you're eating food. Now, sometimes when you're eating food, you realize that some foods are really hot, and you microwave it, and it takes a lot of time to microwave. But then you've microwaved it too much, and now it takes so much time to cool down. Whereas other food, it heats up really quickly, but then it cools down really quickly. So that's all about the specific heat capacity of different substances. Okay, moving on to the next question. Density required practical. Here are some mini questions. So what is the density required practical? This is when you are using the Eureka can to measure the amount of water, to measure the density of a substance. So normally it's with irregular shapes. It's really hard to measure the volume. It's practically impossible to measure the volume of a substance that has an irregular shape. For example, if you have a really oddly shaped water bottle, which is more than likely because it's not going to be perfectly square or perfectly circle. Now, to find the volume of that, then what you want to do is you want to perhaps it's not a perfect square, perhaps it's got some other things in it, and perhaps it was a solid instead, so you can't just fill it with water to find the volume. So if it was solid and you wanted to find the temperature, the volume of this irregular shape, you would put it in a Eureka can. It's important you know the process of this, so let me go through it on the Miro whiteboard here. So if you go through it, you've got your Eureka can, which looks like this. It's got a spout, and that spout is important. So what you do is you fill fill up the Eureka can to a certain water level, the watermark just below the spout. You then, with a piece of string and your irregular shaped object, because imagine you want to find the volume of that, you then slowly lower it. You don't want it to splash in anywhere. So you slowly lower it in the Eureka can, and this causes some of the water to be displaced. It comes out via the Eureka can. So that is effectively how that works and how you can find the volume there. Okay. So hopefully that makes sense for those of you. So looking at the mini questions now, why can't the volume measurements taken only be used since they give precise readings? Well, you need to repeat readings to show that the readings are close together, because you don't want any random value for your volume. You want to repeat them to make it very limited. This is for AQA, yes, and it's also applicable to Edexcel, but to an extent. It's mainly for AQA. Okay, now why is specific heat capacity of ice less than water? Well, the gradient for ice is steeper than the gradient for water. So in this case, you were given a graph and you had to comment on the gradients of the different graphs, which means less energy is needed to increase the temperature. So don't worry if you don't get that, because that was specific to the question, and you had to comment on how the graph highlights changes in specific heat capacity. Okay, the specific latent heat, or the specific latent capacity of fusion is, fusion is less than the specific heat capacity of vaporization of water. How is this shown? Now, I don't think this is applicable to combined higher, but I do believe it's applicable to triple. Do correct me if I'm wrong. So what you want to say here is, this is the one where you have the changing state, as people are saying, and you have a graph to represent it. So fusion and vaporization is representing the two different changes of states there. So you've got a fixed amount from solid to liquid and then liquid to gas. So water takes more time to vaporize than ice takes to melt. Now this means that the decrease of energy is needed to change state. So what they are effectively asking you to do is explain why there's a decrease in energy required to change state, and that's all you have to say. Okay, explain what type of error is caused if the eye doesn't read at the bottom of the meniscus. Now this is broadly for any type of science. So what is the error when your eye doesn't read at the bottom of the meniscus, and perhaps you look at the top? What does that mean? Well, it means random error, because your eye position wouldn't be the same, and therefore it's not the same at each time. Therefore, because the ability for you to read the meniscus wrong is different at each time, and therefore, some people are saying parallax error, so that is a more specific type of random error. Well done, but just know that that's also a random error as well. Okay. Sorry if I'm not able to answer everybody's questions. It's just because there's a lot of people here, so it's a bit difficult to do so. Moving on to atomic structure. We will, after we go through all of the questions for all of the topics, we can have some focus on explaining certain concepts if you want, or go through past paper questions. Atomic structure now. Okay, so the first question, during nuclear fusion, the total mass of particles, what happens to it? What does the total mass of particles do? During nuclear fusion. This is a slightly interesting question. Now, most people are saying increases. No, the answer is decreases. I'm so glad we went through this question. Why does it decrease? Because mass is lost as energy. So during nuclear fusion, the total mass of the particles isn't the same as each of the individual particles. Okay, mass is lost as energy. And that was a question that came up. I don't know whether you learnt this at school, but it was asked about one year. So make sure you know that. Next question. Explain how the process of nuclear fusion leads to the release of energy. So what you want to say here is that, remember, during nuclear fusion, you've got lighter nuclei, lightweight nuclei, they fuse together to form a heavy nuclei. Now it's asking you in this case, explain how the process leads to the release of energy. So what you want to talk about is how some of the nuclei mass is converted to energy via radiation. Okay, it's important to say that step. It happens via radiation. I'm not sure if nuclear fusion is needed and combined. You may have to look at that. I'm not too sure. I just know about the triple spec. So nuclear fusion, you've got lighter nuclei joining together to form a heavier nuclei, and some of that nuclei mass is converted to energy via the radiation that it experiences. Because remember, it's unstable at that point. Okay, moving on to the next one. So before we say that, why was nuclear fusion first tested on models? Well, what you want to say is to make sure that fusion is possible, to assess safety risks, and to assess environmental impacts. Okay, because nuclear fusion is this new sort of phenomena, so it's important to not make any mistakes when they were looking at what are the possible things that could happen, because they had understood that nuclear fusion had caused amazing events in space, so they needed to make sure that it wouldn't be too dangerous to have on Earth. Okay, describe the process of nuclear fission. So it's 3 marks here, so just 3 bullet points. You don't need to specify what type of radiation. You do not worry. Okay, so describe the process of nuclear fission. So during nuclear fission, what happens is a neutron is absorbed. Okay, and a neutron is absorbed, as people are saying, by a large nucleus, not necessarily uranium, but by a large nucleus, and then that nucleus then splits into 2 smaller nuclei. This then releases energy and gamma rays. So the parts in brackets are not required necessarily. Okay, so well done for those people who are saying that. Here are the answers. So a neutron is absorbed by a large nucleus. The nucleus then splits into 2 smaller nuclei. This then releases energy and gamma rays and 2 to 3 neutrons. We are going to do a Kahoot at the end of this. We'll be doing a Kahoot at the end. Okay. So moving on to the next one. What does it say next? Give some man-made sources of background radiation. I'm struggling to read my own PowerPoint here. So man-made sources of radiation. So you can say nuclear weapons testing, that releases a lot of radiation. You can talk also about, here I'll show you the answers. You can talk about a specific named nuclear disaster, for example, Chernobyl, and you can talk about radiotherapy as well. That releases very little amounts of radiation, but that's true. This live is probably going to end at about, let me see. It's probably going to end in like 30 minutes in terms, not end, but 30 minutes more of exam questions, maybe some explanations, and then we'll do a Kahoot. So we're definitely doing a Kahoot at the end, don't worry. And we'll have to do multiple so that everybody can access it. Okay, moving on to the next question. Explain the advantages of radioactive waste having a shorter half-life. So things that you want to say for this are the activity decreases quickly and the risk of harm decreases quickly. Okay, radioactive waste, this is normally from fallout, or if you're using it as energy, as nuclear energy, you're going to have radioactive waste. So you want that to disappear as quick as possible. So either make it the risk of harm decrease quickly, or the activity of it decreases quickly. And hopefully you know the definitions. Okay, moving on to the next question. So, the smoke alarm stays off for a while. Alpha radiation reaches the detector. Why does the alarm switch on when smoke particles enter the plastic casing? So, what you want to say in response to this is simply that the smoke is absorbed and it stops any alpha radiation. So, that's how smoke alarms work. If you're interested, it literally has alpha radiation constantly. And what happens is when the smoke enters, because it will block the alpha radiation, because remember, you've got to think about the ionizing and penetrative power of alpha radiation. Because that is quite low, the smoke blocks it, the smoke is absorbed, and therefore it works like that. For those saying that the count rate falls, yep, that's perfectly acceptable as well for that previous question. You get it to become quiet again, good question, when the smoke starts to dissipate and it can detect that alpha radiation again. Okay. Continuing on, why is it safe to use alpha radiation at home? Think about the different, as we said, the capabilities of alpha radiation. So what you can say is alpha radiation is not very penetrating, or alpha radiation does not penetrate skin, and therefore it's not harmful to human beings. These aren't predicted questions. These are exam past questions that come up a lot, and therefore they're important to go through. Okay. And then the last question, which was a smoke alarm would not work with a radiation source that emits beta or gamma radiation. Explain why. Well, you can say beta and gamma radiation will penetrate smoke and there will be no change and therefore it won't be stopped. It's not that it's absorbed by a sheet of paper, it's that it stops at a sheet of paper. Alpha radiation is unable to go further than a sheet of paper. It can be blocked by it. That's what it means. Remember, think of it, if it can be blocked by a simple gas of smoke, then it's going to be blocked by paper, definitely. Okay, so we're just on to the last couple of questions now. So, this next question. Thank you guys for taking part as well. It means so much that you're answering and still here with me going through the revision. It's lovely to have you guys here. So, Explain explain the ideal properties of a radioactive source for use in medical diagnosis. So what are the sorts of things that you want? I can see people saying short half-life. Yep. We're almost done here. We literally have these last two questions and then we'll do a break and then we'll continue, okay? So short half-life, as people are saying, less damage to cells, less damage to tissues, less damage to organs, less damage to body, low ionizing power, which means less damage to cells, tissues, organs, continuing on, highly penetrating, which means it can be detected outside the body as well. Okay, now finally, the last question of this, explain why contamination of the inside of the human body by radioactive material that emits alpha radiation is highly dangerous. Explain why. So what you want to say to respond to this is that alpha radiation is highly ionizing. This therefore causes an increased risk of cancer. And because it's contamination inside the body, you don't have to worry about it not being penetrating because it's already in the body. So now it can actually do the harm. So alpha radiation is highly ionizing, causes increased risk of cancer, organ failure, radiation sickness, poisoning, mutation of genes, DNA damage to cells. Look at the list of things they can do. It's just endless. Until the radioactive material is removed, excreted, or the activity of the radioactive material reaches or approaches its end, it's quite bad. Okay, and that is it for the questions. So we're now going to do a Kahoot. So if you want to join the Kahoot, I would recommend coming onto YouTube because I'm going to end the TikTok live. So let me just end the TikTok live. Thank you everybody on TikTok for joining and see you on YouTube. You can come onto YouTube to join the Kahoot. If not, thank you so much for coming. Okay. Okay. So, some people want to do past papers and some people want to do a Kahoot. So it's interesting. It's up to you guys pretty much. We've been doing this live for 1 hour and 12 minutes. So we've done a lot of revision and practice questions already. A lot of people are saying Kahoot. Okay, we're going to do a 5-minute break as well because I know some people want to have a little break. And then yeah, you can do past papers alone. That's a good point. If you do want to do past papers, maybe do that alone. We're going to have a 5-minute break whilst I get the Kahoots up and running. So let me just set that. You guys can keep going in the chat and discussing if you want. Oh. Hello everyone. I'm just getting the Kahoots ready. So obviously there's a lot of you guys here, and I guess we're going to just have to do multiple Kahoots, unfortunately, because I do not have premium. I don't really have the time to get it, and also the funds at this point. But I remember that we used to be able to do Kahoots with loads of people. Like I did a Kahoot in January, and a lot of people turned up. I didn't have to pay for anything. This is a bit. Oh, is somebody asking? 1 second. Give me a minute, guys. Sorry about this. For those of you telling me to go into the Discord server, what do you want me to do? I'm a bit lost. I don't know what to do. We are going to be doing a Kahoot. Sorry about that. I can't see it. Sorry, I don't really know how to use Discord too much. I'll go through it later, but I'll start some of the Kahoots and then we can do that. No. The Kahoots are working. I'm just going to get them ready. Physics. Okay. So what topics do you guys want to do? I can't promise that they'll definitely be GCSE level. I hope they will. I'll try and find some good ones. Okay, we'll do multiple, as we have to. So we're going to do the particle model, basics of motion, and energy. Yeah, we're doing a Kahoot. How many Kahoots should I do? Should I do 3 or do we need to do 4? I think we may need to do a lot more than 3. Yeah, what we'll do is we'll do multiple. To get you all into the spirit of things. Okay, so whilst I'll host this first one so you guys can join. Whoever joins this one first, I guess it will be for the first 20 people who access that. Okay, and then once that gets full, I'll show the next Kahoots for you guys to join. So whoever's fast at typing. Okay, so this player limit has been reached, so I'm going to open the next Kahoot for the next 20 people to join. Okay. Um, okay, that's 4. Going on to this next one now. Please, if you can't join the previous Kahoot, join the next one. We're running loads of different ones, so. It fills up so quick. I know, I think you guys are really tech savvy, aren't you? Oh, wow, it's already filled up. Okay, next one's opened. Now, some of them are going to have paper due content, so you can just guess those if you haven't revised. Okay, player limit has been reached. If you haven't joined that Kahoot, join this Kahoot. This is the 1, 2, 3, 4, 5th Kahoot. So 100 people should be able to join. Yeah, I know. I think I need like 8 different ones open. Hopefully my computer doesn't crash. Okay, I'm going to start the game for the people who've joined the other ones. Or you guys should be able to see the questions on your page, so you don't need to look back up at the screen. Okay. Thank you, guys. You're very kind. I love you guys as well. You're so kind and sweet, and I hope you get the best grades possible because you're putting so much effort in your revision. Okay, I just need to change the question for everybody. I'll try and show the scoreboards, but I have to go through 8 different games, so bear with me. That's the scoreboard there. Scoreboard for this game. We'll have to maybe look at the scoreboards later. I'll start the game for the last group of people. Okay. Scoreboards. For those of you, you can keep YouTube open and you'll probably see the scoreboard at one point or another. Well done, Blaze. I'll try and shout people out. Well done, Jay and Sahil. For this group, well done, Erin and Tate. I wonder where that name's come from. In this group, well done, A. Well done, Nicola. Well done, Jojo. Your names are so funny. For this group, well done, E. I can't even say Aziraphale. B-E-J, potato. For this group, well done, Blaze, Sylvie, L-B-A-Q-A. Well done, J-O, combined, W. Well done, Zong. J is on a streak. Past school's doing well as well. K-E, well done, guys. I'm sorry for the people who didn't get to have a go. Jojo is now at the top of one of the games. E is at the top for the next. Sylvie has overtaken Blaze. J, O, and M winning there. Still answering. Bob, Jar, and K. And those people are still answering, so we'll skip. Okay. Well done, people there. Can we do one more game? I'll try my best if I can get through to everybody. It's so weird. I've got like 7 different tabs making so many different sounds on my. I'll try and do one more game. Give me a second, everybody. Let me find one. That's chemistry. I don't know how the computer's holding up. We've got like 14 tabs open. Um, okay, here's the last game for people who want to join that. I hope you're. I don't know why nobody's joining this one. Is there not enough people who want to join it? Oh, you can't see it. Can you not see? That's weird. It's not sharing it. I think my computer's officially given up. It's not sharing the right screen. Let me try and fix this. Give me a second. Yeah, it's not showing the correct screen. Okay, you can see that now. That's the last game you can join if you haven't managed to join any of the other games. I hope you're finding this fun. It's fun kind of doing all of the games at once. Yeah, I'll sort the Discord out afterwards. I'm so sorry about that. It's just because I don't have enough time to sort all the games out. I'm sorry. I like the little Discord community. It's so fun. Everybody join that if you haven't already. And if you haven't subscribed, please do. It would mean so much. We recently hit 10K, which is amazing. Okay, check up on the scoreboard. So we've got Jojo at the top, Nini second, Shaylin third. Well done, guys. For this game, you haven't finished answering the question, which is fine. Here you've got Sheggy at the top, Zongzina second, and Maxwell third. Well done, guys. Here you've got Bob first, Aaron second, and Jar third. And we're going to have to start the last game now. Well done for everybody who managed to join that final game. For this game, which I've lost count of, we have AQA at the top, Nomo second, Waffle third. Come on, Waffle, you can win. For this game, we have M at the top, Bob the Builder second, and Aziraphale third. Sorry if I'm slaughtering the name. And I think that those are the games updates. Okay. I'm glad you're finding this fun. Yeah, I'm gonna have to give my computer some help after. Waffle is doing amazing, and yes, there is bias. Of course, there's going to be bias. Okay. Looking at this game, who's taken the lead? You've got Wizard of Oz at the top. Good name. Noah for GCSE second. Come on, what are you doing second place? Get to the top. Okay. You've got Bob still at the top. Shaggy first and Maxwell second. Jay still at the top with the answer streak of 11. Really well done. And then O and then K, which is an ironic order. Then you have AQA still at the top, Nomo second, Waffle third. Come on, Waffle. M the top, Bob the Builder second, Aziraphale third. And Nini at the top, Jojo second, and Shaylin third. What are you guys talking about? I don't have any bias. I'm completely equal to you all. Wizard of Oz still winning in this game. Bob still at the top. Shaggy still at the top. Seems like the winners are still winning, guys. Put some pressure on them. Jay has got an answer streak of 12. Let's see how long this can last. No pressure. Waffle is making a move up the board. Amazing. Doing my name proud. This one hasn't finished yet. And then we've got Nini at the top still. M still at the top. Okay. Yeah, I'm surprised no one did some really weird names. I guess I should hate Waffle, shouldn't I? Oh, hi, Mariam. Yeah, I know. I don't know how the computer is keeping up with it. That's very true. I shouldn't support waffling. Well done for those who are quite observant. Okay. M still at the top. What can I move into this game? AQA still beating us all. I guess that's very good reflection of the real world. J at the top with an answer streak of 13. See, the pressure is good. This scoreboard stayed exactly the same. Bob still at the top. And Wizard of Oz first. No Waffle falling to third. It's okay. You can make a comeback. Nini at the top, Shaylin second. Could she overtake? Okay. Yes! Waffle, I am so proud of you with 14 correct answers in a row. You are doing amazing. Keep it up. Now I just need Noel for GCSE to win as well. Jay still winning. Well done. Answer streak of 14. Pressure, pressure. Shaggy, but Maxwell with an answer streak of 8. Well done. Bob, B rising. Let's see if anyone can shake that board. Rizidov's first, Matt second, Jelly third. I know, what a cute little community this is. Oh, I'm sorry for jinxing you guys. Well done, Nini, still at the top there. M still at the top there. Oh, this game has finished. So third place, you've got Waffle. It's okay. You've still made me proud. Second place, you have AQA. So who's won then? First place is... It's okay, Mariam, don't worry. Is that Chidima? Chidima, keep it up, girl. I know. You've attended so many of my live streams as well. Really well done. Okay, I'll organize another game for the people who've just finished that one if you want. But let me just start the rest of them. Well done, Jay. Wow, Azzy made a big return, a big comeback. Well done, Chidima. You're like the dark horse in it. You came back with a bang. Okay, I'm going to skip this question so that we can get through to them. Matt at the top. Well done, Matt. Hopefully these questions are actually good and challenging you. I don't want them to be super easy or super hard either way. J is still at the top there. M is still at the top there. What is it with the one-letter names, guys? And then Nini still at the top. Okay, let me sort another game out for the people who've just come out of another game. I'm going to get another code. Let me do another Kahoot for you guys. I mean, it's hard for me to tell how you guys are finding it, so just give me some feedback. If you like it, we can continue. If not, we can maybe move on to some past paper questions. It's up to you what you want to do as well. Once everybody's finished, everybody's going to end up finishing at different times. I hope I don't give you guys the same questions, actually, by accident. Okay, for those of you who have finished a game, you can join this game. Okay. Well done. Nini's still at the top here. Oh, I should keep that tab shared. M still at the top. Well done. J still at the top. Come on, guys, you can challenge them. Shaggy still at the top. Bob still at the top with B moving up slowly. And ooh, E is first, Matt is second, and Jelly is third. Okay, interesting. Thank you, Menashe. I appreciate that. Okay, has everybody joined here? Okay, that's all 20 people here. So we're going to start this game for the people who finished. I'm sorry if you couldn't join. I'm very sorry about that. You guys are very fast, aren't you? Okay, for the new people, Russian RuPaul is first, Hafiz Saab is second, and Av is third. You've got M at the top here still. Bob the Builder is second. Here you've got Nini still at the top. Shaylin second. Jojo third. We've got the podium, so another game has ended. Third place, you have O, well done. Second place, you have Combined W. And first place, you have J. Well done, guys. Well done, all three of you, and well done, everybody who was in that game. Well done, the runners-up K and R as well. I will start another Kahoot if you want to play that. Yeah, well done. I'm second, Miss. Well done. You guys are doing quite well. Bob is still at the top in one of the games. Shaylin has moved to becoming the top. Okay, it's changed here. Well done, Shaylin. I hope I'm saying your names right, by the way. Do correct me if I'm wrong. Hafiz Saab is top. Wilhelm is second. Av is third. Waffle is fourth. Okay, I need to start another Kahoot for you guys who've just finished one. If that's what you want, of course. You don't have to join if you don't want to. Oh, okay, another game has finished. You've got third place, Nini. Well done. Second place, Shaylin. Well done. And first place, who is it going to be? Jojo. Well done, all three of you. You guys maintain the top 3 spots throughout. So really well done. As I said, I need to actually start another game for the people who've just finished. Give me a second. Well done. I hope I don't end up giving people the same Kahoot that I've just given people. Because that would be quite funny. I'm not sharing my tabs, am I? Okay, 1 second. Okay, so here's another Kahoot for you guys who've just finished, and I'll make another one. Okay, if you were unable to join that one, then you can now join this one, and that game I will start immediately, okay? So if you're unable to join that, then join this new game that I've just started. Okay, so if one game has finished, the basics of motion. Third place, Azzy, well done. Second place, Maxwell, well done. And first place, Shaggy, well done, guys. You can join the Kahoot that I have on screen if you want to try again, but well done to everybody playing that game. Oh, another game has finished as well. Third place, Leon, well done. Second place, M. And first place, Bob the Builder. Who would have thought? Well done, Bob the Builder. Okay. I'm just going to set up some more Kahoots if you want to do them. If not, you can leave, and that's absolutely fine as well. Some games are still playing. Wow, that's quite long, isn't it? Okay, so 8 people can still join this game. And then after that, we have another game that you can join. Oh, but you cannot see my screen, which is so funny. Or can you? I love Noah Fall. I love your name. Okay, I need to let some of the games continue. Well done, Shaylin is still top. Jojo is second. Okay, if you're unable to join this game, then you can join this game here. Well done, Hafiz Saab. Well done, Chidima. Still doing me proud. Well done, TJFOZ. Well done, Bob. You're still at the top. And M is second. Well done, E. You're still at the top. Matt second. Jelly third. I'm winning is first. Football is second. And Shaylin is third. Is there still some of you who are not in any games? If so, and you want me to start any, I can try and do that. But obviously there's still that game on screen available. I know some of them have a lot of questions. Well done for those who are still surviving. Jelly has made it to the top. Well done. For the people who are doing this, you're on your last question. So let's share this tab. Bob is at the top. Let's see if that will change. Last question for you guys. Okay, and the podium, the results for this game that's still going on. B is third. Well done, B. Second is M. And first, please be a name I can pronounce, is Bob. Well done, Bob. So you've had 2 winners called Bob, which is quite ironic. Well done. Okay. Well done, Hafiz Saab. Okay, we've got 20 to go. We're going to start that game. Pass Cool is at the top. Joe Mama is second. Okay, I'm Winning is still first. Okay. There's only a couple of games playing now, so if anybody does want to play another game, just let me know. But there are. You're probably tired by this point. Pass Cool is still winning here. I'm Winning is still winning here. It's like they've manifested it. Q is at, oh, Strawberry is now at the top. Aziraphale second and Q third. Joe Mama is first. Jelly is at the top here with Matt second. It's okay if you guys want to leave as well and do your own revision. This is kind of just supposed to be fun revision. Well done, Noshi, you're at the top there. Aziraphale, well done. Joe Mama still at the top. I'm Winning, still winning. Strawberry at the top again. We're probably going to end the live in about 10 minutes, so we'll try and see if all of the games can finish till then. Because I think all the games are full, unfortunately. I don't think there's any space for any. Do you guys want to make a new game? I think we're going to end the live at 9, so I don't think we would have time. Strawberry still at the top. Well done, Noshi. I'm winning, still winning. It's okay if you're not on the leaderboard, as long as you're doing the revision. That's the best thing. Bigger props to the people who are not only doing well, but also are typing in the YouTube chat. I don't know how they're managing. Okay, for the people who have Matt top, Jelly second, Konu third, you're on your last question. Football has now overtaken, I'm winning, and Z has moved up. Well done. Okay, so the winner's third place for this game, you have Konu, well done. Second, Jelly. And first place for this game, Matt. Well done, all 3 of you, and well done, all 20 of you guys who are playing in that game. Unfortunately, I'm not doing any more, so maybe you can play along with this, the last couple of groups, as we get through. Really good job, though, guys. I admire your dedication. Aziraphale has overtaken Strawberry. Joe Mama still at the top. Football is on a winning streak of 11 questions correct. Everyone got this question correct. You guys have improved. Well done. Strawberry now back on top, reclaiming her position. I'm assuming it's a girl. Football still first. I'm winning second. Shaylin third. Is Shaylin going to make a comeback? I'm glad these Kahoots help. 234 Mola making a comeback with 3 in a row. Well done. Strawberry on a streak of 10 answers correct. Well done. I don't want to butcher your name. Sheharyar. Well done. You're at the top. Joe Mama second. I'll do the Discord thing once we get through all of them. The games are almost finishing now. Last couple of questions for everybody. Hafiz Saab has made a comeback. Strawberry's there. Aziraphale, 11 answers correct in a row. Bob the Builder trying to make a comeback. Okay, we've got winners of this game. So third place, Shaylin, well done. Been on the podium twice now. Second place, I'm winning. Okay, and first place, Football. Okay, well done, guys. Amazing. And well done, fourth, Jojo, and fifth, Zed. And of course, everybody else who's been taking part. Strawberry still at the top. Everything could change at the last minute. Noshi at the top. And we've got the podium now. So Bob the Builder has come 3rd place. 2nd place is Joe Mama. And 1st is Shehryar. I hope I'm saying your name right and not butchering it. And well done, 4, which is Pascal, and 5, which is Ali. Well done, guys. You have done amazing. Thank you for joining. We're just on the last couple of games now. It's almost done. Last question for this group. Bye, Zuleika. Good luck. I know you're going to smash your exams. Okay, and the podium for this game, we've got 3rd place. Chidamar, well done, made the podium twice. 2nd place, Wilhelm, well done. And 1st place, Noshi, well done, guys. And well done, 4th, Hafiz, and 5th, oh, it's gone, so I can't see, but well done to everybody who's played that game. And just moving on to the final one now. There's just one more question left. Let's see who will take the win. Well done, Fierce. Okay, and the podium for the particle model 1, which is the final one, Zerafel, 3rd place, well done. 2nd, Strawberry. And 1st, Maxwell. Okay. 100% well done, guys. You've done amazing, and you put so much effort into it. I think we had in total 20 different games going on, so that's amazing. Thank you for staying all the way till the very end. I know you guys are going to get amazing scores. Don't stress. Okay, you're going to do amazing. If you have any questions, do let me know. But yeah, and it's been so fun. Okay. What is tomorrow's live? Tomorrow's live/lives, let me check. We're going to be doing lives on French. No. So, sorry. Tomorrow we're doing an English language, and then Thursday will be French. Okay, perfect. So if you're going to be here for the English language, remember we've already done a question 5 live, so it's just questions 1 to 4 we'll be going over. Make sure you watch that before you come to the live. Yep, English language tomorrow. Okay, guys, thank you so much for attending. I will sort out the Discord thing now. But yeah, see you later. Thank you, guys. You're so sweet.